Hi everybody, welcome, welcome. Happy first day of fall. I am so excited for that. Today we're going to be talking about turning science lessons into STEM connections with hands-on kits. My name is Samantha Bonelli. I am the Physical Science Category Specialist here at Wards. So I'm very excited to be here with you. So our objectives today are to incorporate STEM into your daily teaching activities. I'm going to be showing you 3 hands-on kits specifically from United Scientific. So those kits are chemistry of invisible inks, ink chromatography and forensics, building and designing batteries, an advanced electrochemistry STEM kit, and an extra bonus for everyone here. All of the kits I'm going to be talking about today are linked to NGSS. So that's definitely helpful for everybody. So what is STEM? Let's start by talking about a little bit about STEM. We know it stands for science, technology, engineering, and mathematics. But what does that really mean? So STEM is education for a new generation, an interdisciplinary approach to science, technology, engineering, and math using inquiry methods to develop problem-solving skills and draw real-world connections to the workforce and the community. So get our students ready for the real world right away. So I'm going to be outlining some of the STEM NGSS concepts that are going to be brought to life in these kits. I'm pointing in the wrong direction. The kits are right here. Those aren't the kits. These are the kits. So first we will do science. So the science aspect of STEM, I'm going to outline a few specifics. So first, we will design and conduct scientific investigations. We will use technology and mathematics to improve investigations and communications. We will have conceptual principles and knowledge guiding scientific inquiries. Scientists rely on technology to enhance the gathering and manipulation of data. They're contributing to the advance of science. The accuracy and precision of the data and therefore the quality of the exploration depends on the technology used. We're going to identify a problem or design an opportunity. We are going to implement a proposed solution and evaluate that proposed solution. So those are the science aspects of STEM that we're going to be discussing today. The next, obviously, is technology, which entails an identification of the criteria and constraints of a product or system, begin the design process, create a prototype to test a design concept, refine that design, evaluate the design, communicate observations within the group, which is a huge point for the students. STEM definitely teaches them many communication skills that they'll need in the real world. Last but not least, operate the system to validate the design. Those are all of the technology aspects of NGSS that will be covered today. Next, E for engineering. We're going to be studying design systems, processes, materials, and products, creative processes for identifying and solving problems under constraints, effectively using technology systems, last but not least, understanding that decisions are affected by technology. And one more, we're on M for math. We're going to be formulating questions that can be addressed with data and collect, organize, and display relevant data to answer said questions. We're going to be building new mathematical knowledge through problem solving. We're going to be using reasoning and proof as fundamental aspects of mathematics. Understand how mathematical ideas interconnect and build on one another to produce a coherent whole. And last but not least, create and use representations to organize, record, and communicate mathematical skills. So those are all of the NGSS STEM building blocks that we're going to be discussing in these kits today. Okay, so the first kit that I'm going to discuss, I'm going to be discussing 2 of them in detail and doing the third activity with you. So there'll be some talking for a while, but I promise it will pay off at the end. So bear with me, we're going to see something really cool today. So the first is chemistry of invisible inks. The topics in that include matter's physical and chemical properties, elements, chemical molecules and compounds, mixtures and reactions, evaluating types of ink, visible spectrum of light, and we'll study the pH of paper versus the pH of a document, because once the students put ink on the document, the pH of the whole changes. So that's definitely a topic that's highlighted in this activity. Skills and concepts linked to NGSS. So here's a list of specific concepts from this box kit from the list that I gave you earlier. So this one specifically will highlight design and constructing scientific investigations, identify a problem, propose a plan, propose a solution, evaluate the proposed solution, formulate questions that can be addressed with data, and collect, organize, and display relevant data, and use reasoning and proof as fundamental aspects of mathematics. Now I'll give you a couple examples of those. So for example, identifying a problem in the chemistry of invisible inks. What is invisible ink? How do I make invisible ink? Next, for example, proposing a plan. The students can lay out a design of the entire experiment. That's part of that specific branch. Proposing a solution. Which project worked best in your classroom? And for example, evaluating the proposed solution. Why did you pick that combination of ink and developer? So just several things that can be pulled from these labs that can promote the NGSS activities. So next we'll talk about the activities in chemistry of invisible inks. There are two. First is investigating organic fluids as invisible inks. The second activity in this kit is investigating chemical reagents as invisible inks. So what the students will accomplish by using this chemistry of invisible inks STEM kit. They will understand the history of invisible inks. They will make invisible inks from a selected recipe. They will determine the mode of action of various chemical and physical properties. They will understand the difference between transmitted and reflected light. They'll develop comparison criteria for evaluating the effectiveness of invisible ink. Last but not least, the students will recommend the most effective invisible ink and developer combination. So I think that sums up chemistry of invisible inks. So next is ink chromatography and forensics. This is very similar to the one I just discussed. This one is slightly more advanced because we're adding chromatography to it. So obviously topics include principles of chromatography, mixture separation and molecule affinity, gas, liquid, paper, and thin layer chromatography, molecule polarity. Wow, it feels like a Monday. I'm so sorry. Molecule polarity, RF values, ink dating, ink composition, and visible spectrum of light will be highlighted in this STEM kit. Skills and concepts linked to NGSS. We have conceptual principles and knowledge guiding scientific inquiries. We're going to be identifying a problem or designing an opportunity, proposing designs, choosing alternative solutions, implementing a proposed solution, an identification of the criteria and constraints of a product or system, communicate observations, study of design systems, processes, materials, and products. And last but not least, we will develop creative processes for identifying and solving problems under constraints. So examples of this specifically outlined in this ink chromatography and forensics lab. The conceptual principles and knowledge guiding scientific inquiries can be understanding the scientific method, chromatography itself, capillary action, solubility and affinity, absorption, and the polarity of solvents is an example of how the lab ties into NGSS itself. Another example can be an identification of the criteria and constraints of a product or system. So what inks need to be analyzed in this kit? Last but not least, a study of design systems, processes, materials, and products. The students will learn concepts of chromatography and how does chromatography aid in the study of forensics. So like I said, that's just kind of specifics on how this kit ties to NGSS. So the activities in ink chromatography include working with ink lines in an ink database. We will be doing the case of the quivering line and the case of the crossed four. Those are the 3 activities in this kit. So students will accomplish several lessons by doing this ink chromatography and forensics kit. First, they will understand the use of paper chromatography in identifying links in forensics. They will determine the RF value of a set of standards. They will create an ink database. They will practice problem-solving skills in a forensic environment. Last but not least, they will identify an unknown ink through comparison of its colorant constituents in a forensic document. This is definitely one of my favorites. So, building and designing batteries. This I'm going to discuss and then we're going to do it. So this I'm very excited for. So, building and designing batteries is a complex electrochemistry kit to let the students' STEM abilities come out. So this is definitely going to test every aspect of STEM that you've taught them thus far. This is definitely the most advanced kit in the selection for STEM. The topics include electrochemistry and electrochemical cells, oxidation and reduction reactions, half reactions, oxidation states, potentials, corrosion, wet and dry fuel cells, electricity and circuits, and light-emitting diodes. So NGSS again, alignment here. We have design and conduct scientific investigations. We use technology and mathematics to improve investigations and communications. We identify criteria and constraints of a product or system. We create a prototype to test a design concept. We operate the system to validate the design. We study the design systems, processes, materials, and products. We develop creative processes for identifying and solving problems under constraints. And the big old fact that decisions are always affected by technology. That is the big technology part of this NGSS alignment. So some examples again of kit-specific situations. Design and conduct scientific investigations. The students will design the most effective battery. Whoever in the class has the most effective battery. Use technology and mathematics to improve investigations and communications. Create a pile battery, improve its design, see what's wrong with the pile battery, and the students will go back and create a new one with what they've learned in the first step. Another example, identification of the criteria and constraints of a product or system. What needs to be changed to create the ideal battery? Do you have resources that you don't have in the kit that could be used to create a better battery? So this really lets the students think and inquire and use that problem solving to make the best battery in the class. So the activities in this building and designing batteries kit include building a pile battery with voltaic cells, constructing an LED light battery, and building earth and microbe batteries. The students will learn to use a multimeter to measure electrical quantities. They'll learn about different battery types. They'll learn about redox reactions and electrode potentials. Constructing working batteries that meet stated specifications, and evaluating battery performance and power output. So, activity 2 is what I'm going to be showing you today. It's constructing an LED light battery. Now, this is the one that I've created already. We're going to be piling nickel and zinc. Well, first, these papers, these separators are going to be put in this electrolyte, which is lemon juice. I'm going to soak these for about 5 minutes to make sure that they're nice and saturated. So we'll do that. And this is going to be the end result. This pretty battery. We're going to be stacking the zinc and the nickel with these lemon juice soaked papers in between in a very specific pattern with wires on each side. And this one, the lemon juice dried out, so it's not going to illuminate the light, but I'm going to build one right now with you that will. So, sure, I'll just need these to soak in a little more. They're getting pretty saturated. So, I'm going to show you, we're going to switch to the close-up camera. It comes with print instructions. So I'm going to be showing the procedure on stacking all of these. The font's very small, so I rewrote it a little bit in my handwriting as a reference to myself. So there's a specific order listed, and it shows what needs to be stacked where to produce that battery. So that's what we're going to be doing. So we have this nice little object here that will aid in stacking everything so that it doesn't get sloppy. So we will put some zinc down here. Perfect. This needs to go here so that, I wish I had 3 hands. That'd be really nice. Do you ever need more hands? I'm sure it happens to you. So I'll leave that here. Actually, you know what? At the end, you can kind of, that's okay. At the end, once you build it, you can kind of force it in there after. That's what I did with that one, so that won't be a big deal. So we have our zinc. Then we need a spacer. Then we have nickel. Put that on top. And then we have another piece of zinc.
And we have a question coming in from our live chat feed.
Of course. What is our question?
Someone would like to know if all of those circular items are labeled.
The zinc and nickel are labeled. I don't know if you can see, it's kind of reflective. There's a ZN. Oh, like if I flash it in the right direction, there's a ZN for zinc, and then there is an, thank you, NI for nickel. So there's those. And the paper, there's no label on the paper, so there's only one type of paper in the kit. So that's what you'll know to use for the stacking. So good question. That would be very unfortunate if they weren't labeled. So what I like to do is, remember how I wrote it separately right here? I'm going to kind of check those off as I go, since there's about 20 things that we're doing right now. So I'm going to check my work so far. So I have the zinc, we did that. We're going to do the wire after. I've got the spacer, I've got nickel, I've got more zinc, and then I have a spacer. Just so that it gets really complicated, you don't want to lose your space and be looking. They all look the same, so it'd be kind of awful to look and say, oh, where was I? So next we have nickel. Check that off. Zinc. And another spacer. Okay. Nickel. Zinc. Spacer. Nickel. It all repeats, so there's no super secret formula for this. And another spacer. More nickel. Zinc. Spacer. I should have made a song or something to make this more interesting. I'm sorry. I could drink the lemon juice and you can watch my face, but I prefer not to do that. Okay, we did that. More nickel. Zinc. Spacer. Okay. We are almost there, I promise. sticking together. Okay, now we need nickel. And there we go. And in the instructions, it will say that zinc is supposed to be on the bottom because the bottom is the negative end, and there will be nickel on the top because that's the positive end. So in this exact order, we will slide all of these in this case very carefully. Very, very, very carefully. Ooh, okay. I like to do it in parts so that I don't take too much on at a time. Okay. So then we take our wire. They're going to have to spread out this wire. The wire is going to be very tight like this, and we're going to have to spread this out. I did it ahead of time because this is heavy wire, so we're going to need to use a little elbow grease and spread out these and fan them out because they're going to go between the zinc and the first spacer, like so. Just like that. And then, if all goes well, we'll have light. Move this down a little bit. Can you see it? I don't know if you can see it. I have a little illumination on my end. There we go.
There you go.
See it? Whoop, we're flashing a little bit. It's a flickering light. I did that on purpose for Halloween. I made a strobe light. There we go. Sort of. Well, you get the idea. Okay, well, I did it. So that is probably the most complicated experiment in the entire set. So the students can build their own batteries, and then they can test certain aspects, like maybe if they were soaked in the lemon juice longer, the light would illuminate stronger. Or these need to be cleaned beforehand. They need to be sloshed around in warm water and dish soap. Nothing special. So maybe I didn't clean these long enough. Maybe, I only cleaned them for about 5 minutes. I sloshed them around, I let them sit, and then I patted them dry. Maybe they didn't dry long enough, or maybe they weren't washed. Maybe there's a little bit of dirt and corrosion on them. So the students can test all these different types of scenarios to build the ideal battery. So that is super awesome. So that's the activity 2. There are several other activities in this that there's one more simple one, there's the one I just did, and then there's an advanced option. So it gives the teacher some flexibility, and they can do them all in a row and get more advanced as they go. So does anyone have any questions at all? And I wanted to add too that all of these kits that are conveniently located behind me, the ones that I talked about today, they come with CD-ROMs. So if you order a kit and you don't see any paper instructions inside, it is on this nice DVD. So I'll outline what comes in each DVD. This one, for example, I think they all come with the same, yep, they all come with the same thing. We have a teacher guide PDF to print, a student guide PDF, background information, a glossary, an Excel spreadsheet with sample data, which is always very nice. We like to see what people have done in the past and maybe improve on it. And an extra is it comes with videos and PowerPoints to refer to every activity that we've done today. So with every kit that you purchase, there will be DVDs along with them. So that is a great tool. If you have any product questions, you can email our Plus Us team at sciencehelp@vwr.com. But of course, I'll entertain any questions that you have right now, and I'll answer them to the best of my ability. So if you have some stage fright and you don't want to ask me right now, you can type them or you can just yell them out. It's up to you. So if I don't have any questions, the last slide that's showing right now is our product information sheet. So there are 5 kits in this series, this STEM series, and I've listed the title and the item number for you on our website. wardsci.com is where you can access these.
Sam, the discs that were soaked in lemon juice,
yes,
are those paper?
Yes, they are.
And how many come with a kit, and are they reusable? A lot of questions. 3 in 1.
Excellent, excellent question. So first, these are a heavier paper. I think they were a light cardboard, and then they get nice and flexible. They're not, I wouldn't recommend using printer paper or loose leaf because they've been soaking in the lemon juice and they'd be pretty delicate. So these are a light cardboard material, so that makes for the discs to not fall apart. So that's convenient.
We have another question coming in when you're done.
Sure.
Are you ready?
Sure.
Do we have STEM kits geared for elementary kids?
You know, we do. If you supply me with your email address, I'd be able to offline send you some examples of elementary kits that we can use in the classroom that are aligned to STEM. So definitely forward me your information. I think she's asking you right now. So definitely I'll do some research and I'll pull together something for you.
Thank you.
Any other questions at all? Like I said, you can email me after as well. Well, I thank you for coming and happy first day of fall. Go to a, haunted hayride or something for me and have an awesome weekend and the great rest of your week. Okay, guys? Bye, everybody. Thank you.